Please, you should solve. I am just prompting you and I expect you to solve. Okay? So wherever you need my help, you can take my help, but I can't give you unlimited time. Amplitude A. The maximum possible average velocity in time. In time t by 4. Maximum possible average velocity. You can make some sketches and try to get a better understanding of this problem. They are told it is simple harmonic motion with time t in this one. Average velocity. This is this one of x versus omega. Okay. Now they are asking about the so the thing called this is x is equal to a sin omega t. Now if you want to go for velocity, then it becomes a omega cos omega. Correct? So therefore you would be writing the waveform like this. Correct?
Correct.
So this yellow thing would be the velocity wave. Correct? And this white thing is x versus omega. Now they are asking you average.
The velocity curve won't have the same peak as.
Yes, it doesn't have the same peak. Sorry, thank you. So it doesn't have the same peak. So for yellow curve, they should be more or less depending upon omega. More or less depending upon omega. But what is important is the phase. Okay, fine. Phase is the phase. So they're asking you the maximum possible average velocity. So as you can see, the velocity either here, okay, here you see the velocity is maximum. So in a time period of t by 4, this one, I just slightly elaborate this. So here I am going to get the velocity like this. And now they have given a see from here to here, the time period becomes t by 4. And therefore I will have to take it at this point and this point. So this will be t by 4. Okay, and between these 2 points I am having the maximum velocity. So if you take the average of, average means average of the values in this. Okay, then that will be the maximum possible average value. I suppose you got it. This is what the problem says.
Yes, sir.
Correct now?
Yes, sir.
So what is the maximum possible average velocity in time? So therefore, so this period should be t by 4. Therefore now the question is, so from here to here it is t by 4. From here to here it is t by 4. And this point should be halfway between the two. Correct. So what will be the value of the velocity at this point?
Yes, sir. Instead of that, sir, can't we calculate the position at that point set of the particle at that particular instant of time?
No, they have asked for average velocity. No?
Yes, sir. The total distance covered by total time.
That is also possible. That is also possible. So now you go by this curve. You go by this curve, but only thing is now it is going to have the maximum velocity at this point. Correct? You are going to take these two areas.
So all from this curve only, sir.
That's right. You have to take this area. If you want to go by x means you have to take this area. That is, I will elaborate that. Elaborate that. Okay. So supposing you want to take now, because the velocity is maximum here. So you have to take this area and this one. Take the average. So it will be difficult. So why don't we go for this?
Sir, not like that, sir. It is like from the moving position, sir, to that position, the time taken is t by 8, sir. So the position of the particular t by 8.
T by 8.
Yes.
That's right. This point here also. Correct? This is T by 8.
That's not, sir.
T by 8.
And the total distance will be 2 times that, sir. Sir, can't we consider the position? Sir, it has to travel from the position which it is there at t by 8 to at which it will be there at minus t by 8. No?
Correct. Okay. Position only you take. Position only you take. Position only you take. I am taking this position. See, this is position versus graph. Position versus time graph. So now what I was trying to tell you is, this amplitude is A. This point is midway between these 2 points. Agreed? Hello?
Yes,
Agreed.
sir.
Midway between these 2 points. Okay. Now, there is a half power rule which we have used. Half power in AC circuit also we have used. So, this point will be A by root 2. This point. Okay. And therefore, now the average is going to be what? 2 into A by root 2 divided by T by 4.
Yes, sir.
Okay, so that is going to be the thing. So that should straight away give you a root 2 A into 4 by 2.
Yes, sir.
Got it?
Yes,
It is-
sir.
So you get here 4 root 2A by 2. That's what you are going to get, and this should be the option. They should be the option. Okay?
Yes, sir.
Yes, yes.
Done. Got it all here?
Yes, sir.
Yeah.
Yes. Yes, sir.
Okay. Sorry, take it like this. You can take, around this point and this point, because see, this is in terms of the velocity versus velocity will be maximum here. It is going to droop on both sides. So you have to consider the average between these 2 points. Okay? And here too you have done the same thing. Okay? आराम से solve this.
Another one.
For this problem or previous problem?
This problem only.
Okay, do it, man. Do it. Aram se do it. You are putting everybody under pressure. Everybody you are solving. Just solve. Aram se solve. We will discuss every possible solutions. Okay? You also aram se solve. Let everybody solve. Don't be in a hurry. So I think you should have drawn a schematic diagram for this. So the schematic diagram we can get hold of this.
Yes.
So this can be the mean position.
Yes.
Okay. And they have told it is moving from point A to B, where velocities are c. Look at, mark the word velocities. It is not the speed. That means it can be, say, this point and this point, A and B. See, the proximities will be same. So then the velocity at this point is also like this, and the velocity at this point is also like this, because the particle is going like this, from the mean position, it is at the same proximity. Correct?
Yes, sir.
And they are told velocity and pass from A to B, where its velocities are saved in 2 seconds. So they have told this is 2 seconds. Correct? Then after 2 seconds it returns to B. That means it will go to the extreme position. You go to this extreme position, the particle will go to the extreme position, that is, it has come like this. It will go here and once again backward. And this also it says they have taken 2 seconds. Okay? So that means now from here to here the proximity is 1 second, and from here to here also the proximity is 1 second. Correct? Hello, are you with me? See, everybody unmute your mic and at least these small problems you discuss. Correct? Proximity is 1 second. And this is only 1/4 of the travel. That is 1/4 of the travel. So 1/4 of the travel it has taken 2 seconds. For one complete cycle, it will take 2 into 4, that is 8 seconds.
Yes, sir.
So this should be the way to handle this. What is the total energy of a particle that is oscillating? Hello. This is a very fundamental problem. So here the entire energy is going to be, the total energy here will be equal to kinetic energy. Here the total energy will be equal to potential energy. Hello? And okay, just try to figure out. Okay, so if you have seen, there is a curve called total energy, and then you have got, say this is x is equal to 0 position if you take, then the kinetic energy is maximum, it becomes minimum, then again it becomes maximum, potential energy is 0, it becomes maximum. I suppose all of you remember this curve. So the total energy will always be this one. So this is the potential energy curve, and this is the kinetic. So this plus this always, isn't it? So the total energy will be equal to potential energy plus kinetic energy. So in the rest position, the rest position means, you see, if you think about a pendulum, this will become the rest position. So the total energy is potential energy.
Yes.
Correct? Will you take it like that? The P of an oscillating particle at rest position is 15 joules. Will you take that as the rest position? Will you take that as a rest position? You cannot take it as a rest position.
Extreme position will be rest position.
Huh?
Extreme position will be rested because momentarily it will have.
Then the total energy should be 15.
Yes.
And there is
Yes,
no
sir.
option. There is no option. There is no option.
Yes.
So now you figure it out. Figure it out. How things can be for this. So at the extreme position, that's what we said. The potential energy must be 0. It is maximum. Okay. But then the total energy is. If you take that as the rest position, then the total energy must be equal to 15 joules. Okay, that's not enough. So now think about a situation like this. Okay, so assume that there is a ball kept here, and supposing you take the object here, right? Hello. Then with respect to this reference, so this has got some potential energy.
Yes, sir.
Okay, and then, well, supposing you left this ball rolling down, so it keeps oscillating like this. Okay, then yes, this body will have both potential energy plus kinetic energy will be totally this way, because potential energy is always with respect to some reference. So if you take now with respect to this, and there is a bowl, and you have kept a marble in the bowl, and that is doing up and down, so it will have at this position, it will have both potential energy and kinetic energy. But hello?
Yes.
But at this position, it is going to have only what? It is only going to have potential energy.
Yes.
Okay, so here the question is that the word rest position. Okay, the rest position. The rest position here in this case, if you take it as the equilibrium position, then this will be the equilibrium position.
So, but how
It is not at rest at equilibrium.
Pardon?
It is not at rest at equilibrium, sir. How can we consider as rest position?
That's what. See that word rest. See, if you take this pendulum and say you try to apply the thing as a rest position here, then this rest, if you take this as the rest position, then the total energy must be equal to potential energy is equal to 15 joules. So it doesn't mean rest
In
position.
case we are taking a reference level, sir, the answer has to be less than 15 joules, sir.
Answer has to be
Less than 15 joules.
why?
Sir, you take
See now what? See, I have come out with some solution. You tell me why this is wrong. I have taken this as a reference position. I have kept a ball at some height. So at this point, if I just keep a marble here, its potential energy will be mgh. Correct? Agreed?
yes.
Now, supposing this marble is made to go up and down. Then when the marble is traveling up and down at this position, it will have got both potential energy and kinetic energy. Correct? And that is the only way we can think, because the concept of rest position here means what? So if they say rest position is the equilibrium position, then this is one of the possibilities.
so now
Kinetic energy is 5 joules. The kinetic energy is 5 joules. Average kinetic energy is 5 joules. Therefore, the average is what? Mean of 2. Mean of the two maximas. So maximas means what? Once the ball will go like this, and second time it will go like this. So if you take one maxima like this and another maxima like this and divide by 2, okay, then you are going to get 10. So 15 plus 10, that way also if you add, it is going to be 25. So I will go with 25. Fine. Now we have to, see this at rest position. So rest position means what? Okay. So the body momentarily comes to rest during oscillation. So that is the word they have done. Momentarily it comes to rest. Okay. During oscillation it comes. There is another concept that you keep it, you leave your hand. Don't disturb it. So it is in the rest position.
sir, but
Okay. Now listen. So these are the two places where that word rest comes into picture when we are talking about oscillation. So going by the first one, that is momentary rest, then the total energy has to be 15 joules. Okay. There is no option. Right? So then we have to go with the second option. That is my logic.
So for your logic, sir, one more thing is in the question they have said P of an oscillating particle, which means that particle is already oscillating.
Correct, Baba. See
that it is at rest and then you make
then you go by your logic. You will not. You are nowhere near the answer. Okay.
I'm getting 10, sir.
You are getting what? 10? No.
10.
No. 10 cannot be the answer, man. 10 cannot be the answer because the total energy cannot be less than the potential energy. Why are you not understanding? The total energy
of particle at any instant means
it should be greater. See, the total energy will at any position will be potential energy plus kinetic energy. No,
yes,
it has to be greater than 50. No, it has to be greater than 50. No, how can it be less?
Frame of reference thing.
Hey, how can it be less? How can the total energy be less? See, that one, that basic theory you don't deviate. The total energy of an oscillating particle is E plus P. That is fixed. So the total energy has to be.
Thing is that it is not less than 15 joules, correct? But now when we are shifting the like if you said in the case of that bowl and frame of reference is below, in that case,
See, listen. That's what I'm trying to tell you. Don't unnecessarily confuse. They have chosen some reference. With respect to that reference, they have got a positive potential energy. Now you see, you should not unnecessarily change the reference unless it warrants. It is not warranting here. The total energy has to be greater than the potential energy. That is fixed, or equal to potential energy. Okay, it cannot be less than potential energy. Okay, that is the basic rule. Now don't deviate that rule. Right. So that means now there is a value of kinetic energy which is greater than 5.
Yes, sir.
Okay. So going by that logic, I have added the kinetic energy to this potential energy 15 joules. Okay. And if you add only the average, okay, so you will end up with 20. So it should be greater than 20. See, Abhi now listen. Hello.
Yes.
See, now
Yes.
if you take the part, see, if you are taking this bowl, okay, if you are considering the particle here and if this particle is oscillating, so at this position, it is going to have maximum kinetic energy, agreed?
Yes.
This is going to have maximum kinetic energy, right?
Yes, sir.
And now, if I take it with respect to this reference, this also has potential energy.
Yes, sir.
And this maximum kinetic energy has to be greater than 5 because they are told the average is 5 joules.
Yes, sir.
Isn't it? Correct? So therefore, I am going with that logic and saying that 15 plus 5, 20, it should be greater than 20. That's all. No more arguments. I have explained this. Please go with this.